Purposeful Nudge introduces the AI infrastructure reckoning. Unit economics in the post-subsidy era will drive change in the field.
In October 2025, Microsoft ends support for Windows 10. For IT leaders, this deadline means a massive hardware refresh is already in motion. But this refresh cycle lands right in the middle of a major architectural shift. You can buy traditional hardware today to save upfront capital, or you can pay the pioneer tax for AI PCs. This chart shows the projected trajectory of enterprise software processing demands over the next few years. The flat line is the stagnant compute capacity of traditional CPUs, while the climbing line represents software increasingly requiring local AI processing power by 2026. Look at the widening gap between these two lines. If you deploy traditional silicon today, that gap represents where your brand new laptops will struggle to run daily software updates long before their 3-year lifecycle is up. Buying hardware right now means making a strategic bet on where enterprise software architecture is heading over the next 36 months. To make this bet, we must look at what physically makes a computer an AI PC. It comes down to a single new component, the Neural Processing Unit, or NPU. Let's clarify what this component actually does. If your team relies on browser-based tools like ChatGPT or standard Microsoft 365 Copilot, an NPU will not make those run any faster. Those calculations happen on a server in a data center, not on the laptop. What the NPU does is establish a new hardware baseline for processing AI tasks locally on the device itself. Microsoft's Copilot Plus sets this standard at a minimum of 40 trillion operations per second. This local power is required for agentic AI. These are background tools that independently search your files, draft emails, and execute tasks on your behalf without sending sensitive data to the cloud. The premium price tag on these machines buys the foundational infrastructure required to run those persistent, localized AI agents securely. Let's look at how this hardware impacts a highly mobile or remote workforce. A standard operational load for these employees includes 3 or more hours a day running video conferencing software. Tasks like continuous background blur, noise cancellation, and auto-framing are persistent AI effects. When a traditional CPU and GPU have to sustain that load, they struggle. The resulting strain causes severe thermal throttling, making the laptop uncomfortably hot, and drains 20 to 30% of the battery capacity for every hour on a call. This architecture flowchart shows how an AI PC resolves the bottleneck. Video rendering and background effects route directly to the NPU, dropping CPU activity drastically. This microservice approach generates negligible heat and yields up to 40% longer battery life. For professionals who travel or work remotely, this makes the NPU a critical battery preservation tool that keeps them untethered from the wall. Now consider technicians working on manufacturing floors or remote infrastructure sites. In these environments, relying on cloud-based AI introduces a major vulnerability. If the network connection is weak or disconnected entirely, cloud-dependent diagnostic tools lag or completely fail. The solution is Edge AI. This involves running predictive failure models and parsing diagnostic data entirely locally, using the device's onboard NPU. Processing on the edge guarantees data privacy and zero latency, but it requires IT teams to actively manage and push model updates to the entire fleet. This split-screen visual illustrates the difference. On the left, we see the long, vulnerable round-trip ping of routing data to a cloud server. On the right, the closed loop of on-device NPU inference returns an instantaneous result. When your workforce operates in unpredictable network environments, local Edge AI capability ensures they have functioning decision support tools exactly when a physical failure occurs. Adopting this hardware introduces a hidden financial trap, the RAM tax. Local AI models don't just require NPU processing power. To function instantly, these models must live continuously inside the system's active memory. Basic AI features now require a minimum 16 GB RAM baseline. But watch when running multiple concurrent AI agents on that same memory. It maxes out instantly, creating a severe bottleneck. For these heavy workflows, 32 or 64 gigabytes is the necessary standard. Bumping specifications to this level turns a modest hardware premium into a significant spike in your capital expenditure. Buying standard machines for power users to save capital today will bottleneck their daily work, forcing a mid-cycle hardware replacement that effectively doubles your long-term costs. Knowing the hardware constraints, we can map out a targeted deployment strategy based on specific user personas. This decision tree breaks down the fleet. The first path targets standard office workers who primarily browse the web and write emails on laptops less than 3 years old. For this group, the recommendation is to wait. Let the current hardware depreciate. The second path isolates mobile professionals and field workers. Because they desperately need battery efficiency and offline capabilities, they receive an immediate standard upgrade to a 16GB AI PC using a Snapdragon or Intel Ultra processor. The final path covers data analysts and creatives who are actively losing billable hours to slow processing times. They require an immediate power upgrade to an AMD Ryzen AI machine with at least 32GB of RAM. Aligning the silicone to the specific operational profile prevents underperformance in the field and overspending in the cubicle. There is one final risk to navigate in this refresh cycle: the rapid obsolescence of first-generation AI silicon. The definition of AI-ready is a moving target. Hardware benchmarks and NPU requirements are rising every 6 to 12 months. To protect your capital, consider shifting your procurement strategy away from outright purchasing and towards a hardware-as-a-service or equipment rotation model. Structuring your payments around a 3-year refresh cycle allows you to deploy current hardware now and then seamlessly roll forward into next-generation silicon just as software demands peak. By restructuring how you finance and rotate your fleet, you secure the AI processing power your workforce needs today without stranding your operational budget in outdated hardware tomorrow.